Equation to represent sinusoidal functions. I hope you are getting the concept of representing data of a periodic function as a sine or cosine wave. Now here's question number 3. Write equation of a sinusoidal function with maximum at 135 degrees 6 followed by a minimum at 225 degrees 0. So that is what is given to us. So what we will do here is just sketch a sine function, right? Just sketch a function. So that is how we start normally, right? So I'm giving you a very general method of how to get the equation from the given data. Now we are given maximum and minimum. Maximum is at 135, so the wave must have started somewhere. So let's forget about it for the time being, and let's say, well, this point for us is at 135, right? So this point is 135 degrees and y value is 6 for us, followed by a minimum, so which is this point, which is at 225 degrees and at 0. That means x-axis is along this line, right? So we can easily draw our x-axis. That's good. Now 135 degrees, I'm not purposely drawing y-axis because I don't know from where it starts, right? So at this moment we are not really in a position to draw the y-axis. Anyway, we can write down the equation. Now since we know maximum and minimum, we can always find the axis, right? Axis of the equation is right in the center of this, so let's draw a line here, and this is the value. Y equals to the axis, which is y equals to c. So for us now, c is equal to what? Well, when I say c, what I'm trying to say here is that we could write our function as f of x equals to a times f of k x minus t plus c. Now I'm writing function here. I'm not specifying whether I'm going to write sine or cosine. We'll see it later what to start with, okay? But it could be sine or cosine, right? Now c is the equation of axis. From here we can say we'll do all the calculations on the right side. So we have c as equals to average value of maximum and minimum, right? So we have maximum plus minimum divided by 2, and that gives us 6 plus 0 divided by 2, and that is indeed 3. So now we know c is 3 for us. Now if I know what c is, I can find amplitude, right? So what is amplitude for us? Well, the amplitude is difference between maximum and the equation, right? So that is the amplitude, correct? So let's write down this amplitude a, and a should be equals to maximum minus c, right? That gives us the amplitude. Maximum is 6 for us, c is 3, and so we get a value of 3. So we know a also, correct? Now the question remains is how to find the time period. Now since we are given difference between maximum and minimum, that is half the time period. Do you see that? So half of time period is given to us, and that is equal to 225 minus 135, and this is equal to, we can use the calculator, 225 minus 135, which gives us 90 degrees. So that is half the time period. So time period is basically equals to 90 degrees times 2, and that is 180 degrees. That is the time period. Now since we know t, we can find k, right? We can find k. So the relation between t and k is indeed k is equal to, let me push this page a bit forward. Now k is equals to 360 degrees divided by t, right? So which is 360 degrees divided by 180, and that gives us a value of 2. So we know k also, which is 2, right? So that is how we can get all these values. Now one way is we can start with cosine function, right, and say, well, the first maximum occurs at 135 for us, for example, and the time period is 180, so If I do, so the next will be 180 before that, that is minus side, right? So basically the first maximum which we are getting is at 135. So what we can do is, we can always write this as a cosine function and 135 as our phase shift. So we will use that part since the maximum is given to us. So now we will write our function as a cosine function. The reason is that the phase shift is easy for us, is given to us first maximum, which is at 135. So we'll utilize this maximum to write the value of d, right? And then, so we'll say d is equals to 135. Since this is the first maximum, a maximum which comes before this will be minus 180, right? Time period is 180. So 135 minus 180 is going to give us a negative value. So after 0, that is the first maximum, right? So we can write our function, the cosine function, f of x as equal to, a is 3 for us, right? 3. And we have decided to write this as cosine function. K value is 2 for us, 2 times, right? X, and d is 135 minus 135 degrees. And c for us is 3 plus 3. So that is how we can get our function, right? I hope you appreciate and understand what we've done. It's kind of critical to see why we wrote d as 135. So when we start with cosine function, then what is d? D is phase shift, right? Now for a cosine function, let me write down. For a cosine function, it is x value for first maximum. That is what it is. It is the x value of first maximum. That is what it is. So the first maximum is at 135. Why? Because the previous to this will be minus 180, which will be negative number, right? So that is how we get our equation. I hope you get the concept. It's very important to understand phase shift because that is probably a very tricky part in most of the time when we are representing data in the form of sinusoidal functions. I hope you appreciate it. Thank you and all the best. Have a good look.